So I was very excited to come to NASA for several reasons. The first one being when I was in classes, we learn a lot of theory and we see how things are supposed to be applied in practice, but you don't actually get to go out there and see how it's done. So by coming here to NASA, I was able to do real-world applications and experiences and see exactly how those theories pertain from the classroom to the real-world application. My name is Brandon Cook, and I am a graduate student at the University of Cincinnati, where I'm currently finishing up my Master of Science degree in Aerospace Engineering with a focus in dynamics controls. I am working on integrating UAVs into lower altitude airspace, particularly 55 pounds and less aircraft operating in Class G airspace. Class G airspace is low altitude airspace that is uncontrolled, so vehicles don't have to file flight plans when they're trying to take off or do their operations. There are many considerations you need to take into account when trying to integrate these small vehicles into this airspace. The first and foremost would be safety. You want to ensure that not only your vehicle is safe throughout operation, you don't lose your hardware, but you also want to make sure that everyone around that flight area is also safe as well. One of the major challenges of when trying to tackle this problem would be being aware of your surroundings and knowing where the vehicle is at all times. So when trying to, for example, locate the position of an aircraft, you have very different sources of where that information could be coming from. It could be coming from several radar sources, from a transponder, from GPS, for example. What you have to do is take all these different sources of information and make sure you're using the correct one, the most reliable source that you can. So what I'm doing basically is developing a data fusion algorithm to take all of those different sources of information and trying to select the most accurate one for our case. Once we determine where the aircraft is actually located, we then can send that information to all the other clients that are operating within the Unmanned Aerial System Traffic Management System. So all the operators know where all the intruding aircraft are, and maybe there are some aircraft that are non-compliant with the regulations that you have set in place. You want to know where they are at all times so you have safe operations. There are several phases of testing that you have to go through to ensure that your algorithm is working properly. What we have is some real-world data of radar and GPS information, and what we do is we simulate that coming in at different times because a lot of the data does not come in sync. You want to be able to real-time evaluate that data and get it down to a single output. Once you have finished the simulations, you then want to get into the real world. So at the end of this summer, we will be actually traveling over to Crow's Landing, where we'll be doing a flight demonstration with several vehicles in the air at one time. And there I'll be able to actually test that algorithm with actual hardware flying and see how well it's working. My experience in the SCI program has truly been amazing. I've gotten a lot out of this program. Not only do I get to work with some of the world's experts in air traffic management, but I also have really become accustomed and learned how the research environment really works.
What excited me the most about working at NASA is being part of the space exploration community. My name is Grace Lin. I am currently a PhD student in computer science at UC Santa Cruz. My research interest is artificial intelligence, but more specifically, natural language processing. The Aviation Safety Reporting System collects aviation incident reports voluntarily submitted online and collects information to reduce the likelihood of aviation incidents. My research at NASA aims is to help develop tools that can be used to monitor changes in aviation incident reports. And more specifically, we want to look at changes in the narratives of these reports. So we want to use techniques in natural language processing to help us process the text. Natural language processing deals with computational models of text and speech data. Some of the common tasks include sentence segmentation, part of speech tagging, and just parsing sentences. The major challenge in my research is to figure out what these changes are in the report system. So, for example, is it sentences? Is it keywords? Is it paragraphs that we should monitor, or some other kind of linguistic structure that we need to extract from these narratives? And part of that challenge is to process the narratives because these reports are written in mostly unstructured text format. So we have to deal with typos, acronyms, and just unconventional sentence structures. To overcome the challenges, we search the literature for similar research problems, and we apply the relevant techniques to our data and see how that works out. We also use established natural language processing tools to help us process the text and to help disambiguate some of the language problems we have. By providing these tools that could help the analyst monitor changes over time, we hope that it will reduce the likelihood of the incidents in aviation safety over time. If another student is applying to the STI internship program, I would tell him or her to go for it because you get to tackle real world problems.